Well, I'm sorry if this one's a bit noisy. We've got an air hose hooked up to it excuse me, guys. We've got an air hose hooked up to it to show the floating idlers, as they're called. See if we can see any action on the other one when I do that. Yeah, just a little bit of wobble. Not much really. So, at this speed, there's a lot of shearing going on. I'll turn the air down a little bit. Slow that down. And see if it changes our action. I'm going to spin this one around. So at this speed, there's not a real good connection. At any rate, they're pretty free. They do have a preference in the polarity. It always seems to, well, maybe not always. Now these, SGW by the way, these bearings, I didn't soak them. All I did was add some lacquer thinner to the existing grease. So that's what we've got there. So it's slowed down enough now that we are getting some reaction when I move it now. So what about this guy over here, the floating stator? Now you'll notice I have the regular rotor on here now, and so the stator, this floating stator is sitting a bit higher than it was in the previous video. But we'll see if we can get it in there. Now it's going that way. I can get my camera in the right place. You notice too that I've changed my lockdown screw is now nylon. So the interaction we were getting before around that is not there. I hope that air is not so loud that it's overpowering the audio. Oops, shouldn't have done that. Hold on. See if we can set this thing back on there. Yeah, this one has grooves on the side. The other rotor I used is solid, so it doesn't have any grooves to smack it around like that when it contacts it. Well, let's move it over here to this side and see what happens. It's just so interesting to me. The pinning of the magnet and the obvious rotation of the bearings inside on the inner race, which moves with the support. The indicator line's inside the shadow now. Now this will load the system, and I'm going to put this into GW here and see if that, well, that was interesting. Definitely get a reaction on that. I'm spinning this one, so let's see what that does. You can hear the RPMs drop from the loading. Stop it, or it loads it all the way down. In fact, I think what I'll do, turn the air back up to 40 pounds. A little noisier, but it might be able to withstand the load better. This guy's pushed outside of the field there. When it started slowing down, it pushed away. And as it speeds up, it goes towards. Well, these are definitely connected through that field. Absolutely no doubt about it. And it's clearly an opposite reaction also. So if this one's going GW, then this one's going to prefer AGW. So Magluvin probably had some of this in mind when he asked me to do this test. I'm glad he did. We're seeing some interesting things. Get them both going. Now we've got 2 in GW. See what we get over here in this area. Now you can hear the RPMs dropping. Seriously. That's how much load these guys put on the system. Quite a bit. Quite a bit. So no real gain, you know, from the GW by itself. All I ever see here is loads. You know, I don't see any gains when I scope it, when I graph it. No flat lines, nothing that indicates that I'm seeing a reduction in friction or a reduction in load, you know, throughout the RPM range. So whatever was causing that in owls, I don't know. Now this is the modified 4mm spindle, and I may have to try the JVC spindle. That's it for now.